I need you to choose what to drive for me when you have the chance.
All right. So what are we working on? What are we working on today?
Using the distance formula.
Okay. What did you just say? I'm having a little bit of a difficulty hearing you. Hold on. Let me turn my sound up a little bit. Yeah, that should help.
Right. Using the distance formula.
Okay. What is the distance formula?
D equals x. Hang on.
Always starts with square root of.
Okay. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared.
Correct.
Okay.
Now let's talk about that for just a second, because that's a pretty complicated thing to remember. But it's not that hard to remember the distance formula. If I have a point 1, 4, and some point over here that's 5, 2, well, notice that that distance is always the hypotenuse of a triangle. Right?
Mm-hmm.
So the distance formula is very much related to the same formula for the hypotenuse of a triangle. Well, if I had this triangle and that was the distance x and that was y, well, that would be the square root of x squared plus y squared. Okay? So the way I remember the distance formula is I think of the Pythagorean theorem, and it's the change in x squared plus the change in y squared. And the reason I write it like that is because it doesn't really matter the order you put these in. You could do x1 minus x2 if you want it, because when you square it, it doesn't matter if it's positive or negative, it's going to come out positive. Okay, so when you're substituting for that, you can even reverse them. Unlike slope, if you'll remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can reverse these as long as you reverse both of them. But if you reverse one and you don't reverse the other, you're going to get the wrong sign on your slope. Well, not so when you're using the distance formula. When you're using the distance formula, you can reverse them. So if it's easier to subtract 4 minus 2 and 5 minus 1, you can do that. Okay? The only time the distance formula is not the hypotenuse of a triangle is when it's a horizontal line or a vertical line. If it's either of those, then the distance is easy. It's just the distance of the x-coordinates, the difference of the x-coordinates. Same thing with the distance of a vertical line. It's the distance of the y-coordinates. So the only time it's hard at all is when it is a line with slope, like that. But just know that that line is always the hypotenuse of a triangle that you can create. And this side is the difference in the x-coordinates. That side is the difference in the y-coordinates. Okay? Do you have a specific one?
Yeah.
Okay. What are your two coordinates?
Well, it says find the perimeter of the triangle.
Okay.
With vertices 8, negative 2, 1, 5, and 4, negative 5.
1, 5, and 4, negative 5?
Uh-huh.
So somewhere down there. When you're doing this, when you're drawing a picture, it's not that necessary to be accurate. In other words, you'll notice I did not put a grid on my graph. I just put in the points. Okay? To find the perimeter of that triangle, we have to find the distance between every 2 points.
Mm-hmm.
So let's call that A, let's call that B, and let's call that C. What is the distance from A to C?
Well, hang on.
Square root of what?
8 minus 4 squared
Okay.
plus
So that's 4 squared.
negative.
It's the distance from
2
minus 2
plus
to minus 5. So all you need to know is the absolute distance. You don't need to know its sign. So if I got a point minus 5 on the number line and another point minus 2, what's the distance between those?
Well, the distance is 5 between A and C.
Hold on. What's the distance between y sub 2 and y sub 1?
3.
Okay, so I can put a 3 squared in there.
Yep.
Okay, so now it's the distance square root of 25. Okay, so that distance is 5. Now,
Yep.
now let's figure out B to C. Square root of what?
Would I use B as Y2 or B as Y1?
Yeah, if we're going from B to C, the only thing we care about is the distance between the x coordinates and the distance between the y coordinates. What's the distance between 1 and 8?
7.
What's the distance between 5 and minus 2?
Negative 7.
Or just 7?
7.
Like I said, we don't care if it's negative. We're squaring it. So that becomes 2 root 7. Okay, in other words, that's the square root of 98, which is the square root of 49 times the square root of 2. Whoops, hold on. Square root of 98, which is 7 root 2. I had it backwards. Okay, and finally, what's the distance from A to B? So this is 7 root 2. What is A to B?
3 squared minus or plus 10 squared.
That's probably not simplifiable. Guess that nothing divides into that. That's got to be primed. Yeah. So that distance is square root of 109. The perimeter is the sum of them. So the perimeter would actually be 5 plus 7 root 2 plus root 109. The only number that I would think might divide into that is 9, but you'll notice that for 9 to be divisible, the digits have to add up to 9. These 3 digits add up to 10, which means it's not divisible by 9, it's not divisible by 3.
So that's the answer then, is 5 plus 7 square root 2 plus 109.
That's the precise answer. If they wanted you to turn it into a decimal, you could do that and approximate it and round it off, but they would have to tell you how many decimals they want it rounded off to. But if you want to give an exact answer, this is it.
Okay. Ready?
Yeah. You got another one that's different than the distance, or?
No, they're all distance formula. But it's a word problem.
Okay.
So Josh is riding his mountain bike when he realizes that he needs to get home quickly for dinner. He is 2 miles from the road, and home is 3 miles down that road. He can ride 9 miles per hour through the field separating him from the road and can ride 22 miles per hour on the road.
Let's see, he's 2 miles from the road, and the road is 3 miles to his house.
Yep.
So we'll make that 4 and that 1. Does that fit the picture accurately?
Yeah.
Okay, and the question is what?
If Josh rides through the field to point R on the road, which is, it looks to be a point on the ride home, to point R on the road and then home along the road, how far will he ride through the field? How far on the road? Let X represent the distance in miles between point R and the point on the road that is closest to his current location.
What speed can he ride through the field? Didn't it give you?
How far will he ride through the field? If point R is a point between here, hang on a
Some
second.
point like that, R?
Yeah.
And he's going to ride to that point, and then he's going to ride along the road the rest of the way.
No, so let X represents the distance in miles between point R and the point on the road that is closest to his current location.
So,
And his current location is up by that 2, the point at that 2.
let X be the distance between R and that point there. So they want that to be X?
Yeah.
Okay. What else?
That's it. Just how far on the road let X represent the distance in miles between point R and the point of how the road is. So how far will he ride through the field?
Okay. What's the coordinate of this point, the way I've drawn it?
2, 1.
1, comma.
1, 2.
Okay, and what's the coordinate of that point?
R, 0.
So what's the distance between where he's at now and R? So that distance, X, we'll call it, always starts out square root of. Since we don't know where R is, it's going to have to be in our answer. So what's the difference in the X coordinates?
We don't know what the other X coordinate is.
What's the distance?
The difference in X coordinates is 1 minus R.
It's R minus 1.
Great.
In other words, this distance right here is R minus 1. Okay, so R minus 1 is the distance, the difference in the X coordinates. What's the difference in the Y coordinates?
Minus 2.
2 squared, 4.
Awesome.
Okay, so that's how far he rides through the fields. And then how far is it along the road?
X.
Well, what's this distance right here?
3 minus X.
4 minus R.
No, it wouldn't be 4. Let me show you the picture that they put.
Okay, do they put everything at the origin? In other words, they put him here?
It's not even on a graph.
Can you take a picture and send it to me, to my email?
Yes.
Okay. Do you have my email address?
No, I'm just going to send it to your phone.
Well, don't do that, because I can't bring that up. Send it to my email, because I can...
Well, I don't. You don't need to bring it up, do you?
Well, okay. No,
because we can both see it.
You're right. You're right. Okay. So let's see. Just send a message.
It's sending. Sorry.
Okay. Are you sending it like a text?
Yeah.
Okay.
It's taking a little longer than it. Oh, there we go.
In other words, let's see, I'm guessing that the way they drew it, he was here, and that's 3. Is that the way they drew it? And R
Oh, did you get my text?
just arrived. Yeah. That looks like the way they drew it. Let me see here. Okay, yeah, that's exactly the way they drew it. Let me see what they are saying here. I can't, unfortunately, I don't seem to be able to expand this, but I don't think I need to. Let me see if I can read what they wrote. If Josh rides to the field to a point R or on the road, how far will he ride through the field? All right, well, this is actually easier way to do it than the way I did it. In other words, they're saying let x be that distance. This distance is going to be 3 minus r. So this distance here, x, is going to be the square root of r squared plus 2 squared. And the amount that he rides on the road is going to be 3 minus r. In other words, this distance right here is 3 minus r. So he'll go this distance plus this distance. That's the total he will ride his bike. Is that what they want? Is the total that he'll ride his bike?
The distance that he will ride his bike through the field?
So that's just x? So that's just square root of r squared plus 4?
Yeah, that's what it's looking for in the first half.
Okay. And what's the question?
How much time will Josh spend riding through the field? How much time on the road?
Okay. What's his speed and times? In other words, the master equation is d equal rt. What does it tell us about his speed?
Well, through the field, he is 9 miles per hour.
Okay.
And through the road, he can ride 22 miles per hour.
Okay. So, if that's the distance we're going, square root of r squared plus 4, that's what goes for d. So I have the square root of r squared plus 4 divided by his ride rate, which is 9. So that's the time he spends going through the field. The time he spends going on the road is d over r. D is 3 minus r. The rate is 22. So that's the time he spends on the road. That's the time he spends driving through the field.
Okay, and then for part C, what value of x gets Josh home the fastest? What is the minimum time?
Ooh. This is almost calculus. So what path, in other words, what value of r makes t the smallest? Well, let's see. His total time, this is his time on the road, that's his time in the field. So his total time needs to be added together. So it's 3 minus r over 22 plus square root of r squared plus 4 over 9. How do we minimize that? I'm thinking as to what you should, I don't know what they've taught you. In other words, this to me looks like a calculus problem. I'm surprised you're getting it. Unless they're giving you basic calculus questions, which I doubt.
I'm not going to lie to you. When she taught this lesson, nobody really understood what was happening at all.
Well, that's because it's a very unusual question. Usually when you get minimize and maximize questions at your algebra level, even honors algebra, it comes down to a quadratic, and you know that if I have a function like that, well, I know the maximum occurs at the vertex. And if I have a function like this, I know the minimum occurs at the vertex. So if we can set up our time to look like a quadratic function, then we can find the vertex and find out what value of r results in the minimum time. In other words, this on the right is going to be close to correct, except it's going to be something that looks probably like this, where this is r and this is total time. Okay? So based on some value r, it's going to give you a total time that's the smallest. Well, what was total time again? Total time is 3 minus r over 22 plus square root of r squared plus 4 over 9. That's the total time function. Now, how do we tell that? It's not a quadratic is the problem. It looks to me like, unless I've got the answers wrong here, it's possible that I made an arithmetic mistake somewhere along the line. Did you get these same first two answers? Do you agree with them?
Well, I understand how you got them, but I don't understand if that's what she meant because I don't know what she taught us in the lesson.
And that I believe is correct for x. In other words, that's the hypotenuse of a triangle. That side's 2, that side's r. So that's got to be the square root of r squared plus 4. So that's the distance x in terms of r. And this distance here is clearly 3 minus r. In other words, if r was 3, he would not drive on the road at all. If r was 0, he would drive 3 miles on the road. Now, if you were in calculus, there's an easy way to do this. You take the first derivative, set it equal to 0, and solve for r. But given that you haven't had calculus or anything like it yet, I'm not
she
sure.
just wanted us to graph it and find the minimum.
Well, that's not the easiest function to graph. Notice what my function looks like. 3 minus r over 22 plus square root r squared plus 4 over 9. So let's go ahead and let me open up before I let you go here. Let me show you. Did I ever pull up Wolfram Alpha for you the last time?
No.
This is a nifty program that allows you to graph something relatively easy. Well, I'm going to graph this function. Quantity 3 minus, I'm going to call it x instead of r, just because it likes x is better. divided by 22 plus the quantity r, oops, better use the same variable, r squared plus 4 raised to the 1/2, all divided by 9. Extra parentheses, divided by 9. Now here's the beauty of Wolfram Alpha. When I put that in there, it's going to tell me what I put in. Okay? Not only is it going to show me the graph, but it's going to tell me what I put in. That's exactly what I put in. 3 minus x over 22 plus that. Okay, so let's look at that. That's our function. We can see where the minimum is. It's right there. In other words, it is a parabola. And the minimum occurs, it looks like the minimum occurs at 1. R equals 1. Let's see, a lot of times they will give you the mins and the maxes of these things along with the graph. Doesn't look like, they did give us the derivative, but then solving that for setting it equal to 0 and solving it, not the easiest thing. Yeah, they do give us a minimum. It occurs at 18 over square root of 403. And what they did was they took the derivative of that and set it equal to 0. Now, how your teacher expects you to do it, I'm not sure. Because I don't know how you're going to get that answer, 18 over square root of 403. That is the proper minimum. And let's see if that's close to 1. Well, square root of 403 is about 20. So it's very close to 18 over 20. So that is the right answer. It fits this graph. It's not quite 1. It's a little bit less than 1. Notice that graph is not quite a parabola. When they zoom out on it and look at it, that's not a parabola. So it's not the easiest thing for an algebra student to find the minimum on that function. I'm curious as to how she wants you to do it. It's not that easy for me to do, even with calculus. But if it were a parabola, it would be relatively easy. You could find the vertex. But it's not a parabola. So I'm not sure how she wants you to come up with that answer, which is 18 over square root of 403. And what that is the x coordinate. No, that's the r coordinate, actually. In other words, that's r. And it comes at 18 over square root of 403 on the horizontal axis. Okay? And like I said, I have no idea how she wants you to come up with that number. But I'm kind of curious. Next time we meet, I hope you know. Because I can't imagine in Algebra 2 how they want you to come up with the minimum of that function.
Yeah, I'm not going to know.
Well,
She's never going to go over this again.
Really? Okay. All right. Well, you have an answer. I'm not sure how you get it, but or how she expects you to get it. All right, Julie. We're just doing a half hour tonight. Is that right?
Mm-hmm.
Okay. And let's see. Let's talk about next week. What do you want me to lock up for you in terms of the schedule? Right now, I've got you at Monday and Wednesday at 4:30. You want to keep both of those?
Yep.
Okay. And obviously, you can change them if you need to. Try to give me as much advance notice as you can.
Okay.
Okay? All right.
Yep.
I will talk to you Monday. Have a good weekend.
You too.
All right.
Bye.
Bye-bye.